Hello everyone, for today's third and final problem we have a word problem, and it goes as follows. At the Miami Grand Prix, a fan of the Ferrari race team is taking stats of their starting race car. After the race, the fan finds out that the car travels at a speed of 16x cubed plus 2x. This fan is asking for your help to find the velocity of this graph and then the total distance traveled from 0 to 4 seconds. To tackle this problem, we have to figure out what exactly it is we're being asked. So first it says to find the velocity of this graph. From prior knowledge, we know that the velocity of the speed equation is the derivative of it. So if we start with 16x cubed plus 2x, we have to find the derivative of that. And using our power rules, we know that if we do the power rule, we get 36x squared plus 2, which is the same as 1/2 x squared plus 2. Our second step is to graph the derivative, but for the sake of time, voila, we have a graph. And now, the question also tells us he's trying to find the total distance traveled from 0 to 4 seconds. So, we know we have a domain that goes from 0 to 4. So our area is going to be the area under the curve from 0 to 4. And since we're using statistics, we know that MRAM is the most efficient method. So for this problem, I think it is most reasonable that we use MRAM to find the area under the curve. Now it is time to truly dive into this problem. So we established our domain that goes from 0 to 4, and we know our graph is 1/2 x squared plus 2. So now we have to figure out what the width of every rectangle is going to be. So if we use the equation, 4 plus 0, and we know we need 4 rectangles over 4, so each equation Now that we have established what method we're using, which is MRAM, and what our derivative is, 1/2 x squared plus 2, we have to find the width of each rectangle. That will help us approximate the area. So we use the equation 4 plus 0, because that is our domain, over the amount of rectangles we want. So we know we want 4 rectangles. So that means each rectangle is going to be 1 unit wide. So if we go into our graph, we can make a mark at 1, 2, 3, and 4. Now it's time to draw our rectangles. So since we're using MRAM, we know that means we have to start at the midpoint of each rectangle. So on our first rectangle, this is the midpoint. So that means we're going to go up to where it intersects the graph and draw a rectangle. This one, we're going to go up from the midpoint to where it intersects the graph and draw a rectangle. Same with the one from 2 to 3. Up, draw a rectangle. Same with the one from 3 to 4. So it's going to be high. Now that we have established what our rectangles look like and what their midpoints are and the height, we can now establish the area of the rectangles, add them all up, and find the area under the curve. So for rectangle number 1, which is this one, it will be 1 times 2.125. For the sake of time, I found the heights of each rectangle. So that's just 2.125. Area 2 is 1 times 3.125. So that would just equal 3.125. It's going to be 1 times 5.125. So that would just equal 5.125. For the last one, you just have 1 times this height, Bring it down. 8.125. So that is equal 8.125. For the sake of time, you would add these all together, and your area would come out to be 18.5 units squared. And there you go. You just found the area that the car traveled under the curve using MRAM from the equation 1/2 x squared plus 2.